Hello everyone, welcome back to my channel. My name is Sanjeev Garg. Today we will be discussing new problem in our dynamic programming series. So before I start this problem, I highly recommend you to checking my previous video. They will help you to build a solid foundation and make this problem easy to understand for you. Okay, so let's get started. So let's first read the problem. Unique path. So there is a robot on the mcross and grid. The robot is initially located at the top left corner. This is the top left corner, and the robot tries to move to the bottom right corner. Bottom right is this finish point at the yellow sign, you can see. Okay, the robot can only move either in the down direction or in the right direction, down direction or in the right direction. Given the two integer m and n, return the number of the possible unique paths. So from this point to the finish point, we have to find the total number of the unique paths that the robot can take. Okay, so how will go with this? Let's first understand the problem. So unique paths that we have to find. How we will find the unique path? Let's say we have a 2D matrix. Okay, so in the start our robot is here. So robots want to reach here. So there is one condition given, either we can go in the down direction or we can go in the right direction. So let's say if robot is going this direction, now the robot will come here, and after that robot will come here. This is one path. Now let's say if in the down direction robot will come here, after that robot will come here. So this is also a one path. So total unique path that we have to find is here is two path. Okay, so robot can go either in the down direction or robot can go in the right direction basically. So let's see this example with a 3 cross 3 matrix. Okay, let's see this example with a 3 cross 3 matrix. Okay, let's say we have this 3 cross 3 matrix. Robot is here and robots want to reach here. This is the start point and this is the finish point. Let's say this is my, okay, this is my first row first, row second, and this is row third. This is column first, this is column second, this is column 3. Okay, if we are taking as index, let's say I write this is 0, this is 1, this is 2, this is 0, this is 1, this is 2. Okay, so now this position is 2 cross 2. Okay, how? So this point, either what the actually this if let's say this is a function f cross 2 cross 2, what this function signifies, it says that the how many unique paths are there from the start position to reach at this position 2 cross 2. This is the main definition of this function. Okay, so if I'll see this function, what we can do, this function will ask, because it is given that either we can go in the right direction or we can go in the down direction. So its upper cell. Hey, upper cell is which one? Because we are going up direction, so row will decrease. This is 1 and 2, and this is because we are going to the left side, so row will remain same and it will reduce to the 1. It will ask to this one and this one, hey, what are the unique path to reach at you? If let's say on the upper side it will say unique path are 2, and on the left side it says unique path are 3. So what is the unique path to reach at f of 2 cross 2 is basically 3 plus 2, because three ways are there to we can go from here to here, and two ways are we can go from here to this position. So total 5 unique paths are there to reach at f of 2 cross 2. Okay, this is the way. Now let's say my robot is at here. Okay, so robot will ask to its upper position and robot will ask to its left position, hey, how many unique paths are there? Okay, so if its left is not there, we are simple returning as 0. It will ask to its upper side, hey, how many unique paths are there to reach at you? Let's say if this cell says that there are 3 unique paths to reach at me, then how many unique paths to reach at you will be? It will be 3 3 only, because we are coming, there is one path, there is 3 path to come here. So from that path we can go, we can come here also. So there are the 3 only. So if in the tree hierarchy, if we see this problem, so this is, let's say this is function of 2 cross 2. Okay, it will ask to its left side, or it will ask to its upper side, hey, how many unique paths are there? If it asks to its left side, we are going in the left direction, then number of rows will remain same and column will decrease by 1. If we are going in the upper direction, row is decreased by 1 and column will remain same. Similarly, now it will ask to its left side and it will ask to its upper side. Let's say if it asks to its left side, hey, how many unique paths are there? So when we are going into the left side, row will remain same and it will reduce to 0, the column will reduce to 0. For this upper side, when we are going to the upper side, row will decrease to 1 and column will remain same. For this, if the left side we are going, row will remain same, column will decrease to the 1. Okay, similarly, if we go to the upper side, if we go to the left side, if we go to the upper side will says 1 and this will remain same 0. Okay, so as this is negative means there is no column left now. Now it will return 0, it will return 0. Okay, so let's say now I'm at this position. Now it will ask to its left side, it will ask to its upper side, it will ask to its left side. When we are going in the left direction, then the row will remain same, column will decrease by -1. When we are going in the up direction, row will decrease by 1 and column will remain same. This will come to the 0 and 0. Okay, so it means 0 0 represent this, 0 0 represent this. If let's say this is my matrix, 0 0 is represent this first one. If you have seen any matrix, this shall always represent 0 0. If from here I am reaching this cell, means it will return 1 only, it will return 1 only. From here it will return 1, this is minus because it will return 0. Okay, so it will return 0 plus 1. It means that at 1 0, at 1 0, which one is 1 0? Let's say this is try to understand this tree basically. Okay, which one is 0? 1 0, 1 means row, 0 means column, 1 0 is this one. At this position he asking to the minus, its left side, left is not there, it asking to the this one, it asking to this one, and it's asking to its upper side is 0 0. Upper side is saying that to reach at means there is one path, it means to reach at u is also one path, so here one will come. Okay, similarly, if you see this is 2 0 2 0, this is 2 0. Now he will ask to the from the 2 0 from the left side at this -1, so it will return 0. As I know at 1 0 there is one unique path to reach at 1 0. To reach at 2 0 it will give to 1, so 0 plus 1, that is 1 only, so 1 all here 1 will come. So this is the way how we are filling this row, this cell, this cell, this cell, this cell, this cell, and after that at last this cell we are filling. So in this way we are finding basically total number of the unique path to reach at this step. So if you see at each step, okay, what I am doing here is the one function that I need to calculate. Here if you see there are the 2, here if you see there are 4, and the worst case there are 8 here. Okay, so in simply I can write is 2 raised to power 0, I can write his 2 raised to power 1, here 2 raised to power 2, 2 raised to power 3. Total number of cell we have is, let's say if there is m rows and columns, so if we say m rows and columns, so time complexity will be 2 raised to power mn. Okay, order of 2 raised to power mn. If I'll talk about the space complexity if I'll talk about the space complexity is nothing but the depth. If you see in the array how we are going, okay, so we filled this one, this is basically, this is the row and this is column. So if let's say row is m, n is column, so total depth of the stack can go. So let's say if this is a stack, how the stack will work. Okay, so if the stack, so first this f of 2 2 will go into the stack, f of 2 2 will go into the stack. After that f of 2 1 will go into stack. After that f of 2 0 go into the stack. Okay, once they are into the stack, after that once it is resolved, so now its right side means in the right side where this one is decreasing, from this one is this went to the stack. Now this part will go to the stack. So maximum depth of a stack that can take is m plus n only, m plus n only. So the space complexity is order of m plus n, order of m plus n only. That is the stack space. Okay, so now if you see in this graph, okay, if you see in this graph, this is if I'll calculate this one, okay, this is 2 1, this is 2 minus 1. If go to the left side, it also go to the upper side. If I'll go to the left side, it will remain same as this is the minus 1, simply we will returning 0 here. And on the right side, in the right side, okay, let's say if for calculating the for 2 and 1, it will remain same 1 and it will come to 0. If you see 1 0 is here, 1 0 is here, so there are some overlapping sub problems are here, so how we can solve this? These are the overlapping sub problem, this one, this one. So instead of calculating it again and again, recalculating it again and again, can't we store it into an array or in anything? Okay, yes, we can do. So here we comes another approach that we can solve this problem by the memoization. Okay, memoization. In memoization, what we will do, okay, we have this, we will take an dp array of mn, dp array of m and n. Okay, this is the 0 0, this is 0 1, this is 0 2, this is 1 0, this is 2 0. Okay, if my this 1 0 is calculated, I will store in this dp array. After that, let's say at this point, let's say if my this f22 is here f21, f20, similarly on the right side it will be 2. Okay, it will decrease to 1, it will remain same. Okay, so before calculating, let's say I want to calculate this cell. Before calculating, I will check whether this is present in this dp array or not. If it is present, I am not going to recalculate it again and again. Okay, so this overlapping sub problem will get resolved here. So maximum number of the operation, that how much I can do. If you see, this is my array, and this has m cross n matrix, this is m cross n matrix. So total number of the time complexity will be here is order of m cross n only. If I'll talk about the space complexity for the stack is order of m plus n for this stack, but we are taking in a dp array of order of m cross n. So space complexity will be order of m cross n plus mn, m plus n. So it will order of m cross n only, Okay, so this is the dp approach. This is the basically memoization approach, how we can store the value in an array. Now let's start with tabulation approach. Okay, so now let's start with the tabulation approach. So in tabulation, what we can do in tabulation, okay, in tabulation, let's see this matrix. Okay, let's see this matrix. This is our dp matrix, okay, I am at this position. My robot, let's say robot is at this position. So I know that to reach to reach to this position is 1, so it will be 1. So when our cell, when upper dp of 0 0 will be always 1, will be 1, because there is only one way to reach from the start to the start itself, because start is our destination in this case. Now, now how the tabulation, how the this way we fill, how we will fill this way. Okay, we will fill this way. Now I will go to this position, this is my row, this is my columns, this is my columns. Okay, so how we will fill this position, how we will fill this position? There, if I go to this position, there is one way only, there is here, there is one way only. Okay, now my robot is at this position, my robot is at this position. He will ask to its left position, hey, how many ways to reach at you, and it will ask to the upper portion, and maximum of this is filled by this one. This is 1 only, 0 plus 1 is 1 only. Now my robot is, let's say my robot is, let's say at this position. Okay, now it will ask to its upper position and its left position, hey, how many ways to reach at you, at it will ask to the upper position, it will ask to the left position. Upper position will say, hey, there are one way to reach at me, and left position also say there is one way to reach at me. So to reach at this position there are two ways. So if you see, to fill this cell I need this cell and I need this cell, I can easily find with the help of this dp, with the help of this dp array. So how we will go from, okay, so what we can do, we can just simply for int I is equal to 0, I is less than, I is equal to 0, I is less than my row, or I is less than I plus plus. Okay, for int j is equal to 0, j is less than, and j plus plus. Okay, j plus plus. Now we have to fill first, our base case is here. Okay, we can simply here write here, if our this one dp of I of this, if we reach at, if I is equal to 0, if I is double equal to 0 and j is double equal to 0, we will simply put dp of I j is equal to 0 only, we will put dp of I 0 only, and we will continue again in the loop. Okay, we are continuing in the again in the loop. Now what we will do, we this cell is filled. Now this cell is filled. Okay, now this cell is filled. Okay, now what we have to do, we have to fill this cell, next cell we have to fill this cell. Okay, let's say we are going in the, we are filling this cell. To fill this cell, let's make a clear matrix here. Okay, now we have already filled this cell. Okay, this cell we have filled. Now we are going to fill this cell. To fill this cell, it will ask to its left side, it will ask to its upper side. So let's calculate the left side. How we will calculate the left side? Left side will be calculated with function, if we are going to the left direction, then will our row will decrease by -1, so I -1, and column will if I'll go to the, sorry, if we are going to the left side, row will remain same, row will remain same, row will remain same, and our column will, let's say going to the left side, so it will remain same. Okay, so our row will remain same and column will decrease by 1. So I'm asking to this one, this guy, this one I'm asking to this guy, and another one is we are going in the up, we have to ask to the up, this one we have to ask to the up. Hey, if we are going in the up direction, so our row will decrease by 1 and column will remain same. Okay, okay, we will ask from the left side and we will ask to the from the up, hey, how many ways to reach at you, and at the last what we are going to do, we are returning left plus up, left plus up only. If you see one point here, one point here, if you see we are at this position, we are at this cell, and we have to calculate at the left side is okay, but when I am calculating it's for the up position, my I minus way is here, I minus 1 is is negative basically. So before calculating the up, I need to check I should be greater than 0. Similarly for this one here, for calculating my left side, for my left side, okay, so here I'm calculating the our my left side is here, j should be greater than 0. Okay, j should be greater than 0. If I'm reducing the row, so I'm reducing the row, it should be greater than 0, because I want to tackle the negative case where the row is decreased by 1 and we are going from 0 to -1. Okay, so in this way we can do tabulation approach. So in the tabulation approach, if I'll talk about the time complexity, it will remain same, order of m cross n only, and the space complexity will be order of m cross n only, because order of n cross only, we have removed this order of m plus n, the space that we used in the stack, we removed that step, that space. Okay, now if you see one thing here, now let's see the another approach is the space optimization. Okay, in space optimization approach, how can you do this? As I said, let's say this is my matrix, okay, this is my matrix. Space optimization, so if I want to calculate this position, I'm asking to this guy, hey, how many ways to reach at you? Okay, I just need this two cell, okay, let's say if I'm at this position, I'm asking to this cell and this cell, I need just only this cell, means this cell is present in the upper row and this is in the current row. So what we can do, we can take a temporary array, okay, we can take a, let's say, temporary array. Once we are calculating this one, we will, let's say this is my current and this is my temporary. Once this is calculated, let's say this is for this cell it is 1, for this cell it is 1, now it's 1, okay. Now all this row, for the first row we have calculated the values. Now what we will do, we will move this, we will make this as our temp, now temp will be here, means this is my temp and this will become my current. Now at this position, let's say I have to calculate, I need to ask to the my previous, and from the left side I can easily find from my current array and previous from my this temp array. Okay, so in this way we need only just this temporary array. Okay, so basically we are taking only one array, instead of keeping complete dp array, means we are taking dp of 1d array. 1d array is just for one column, one row. Okay, so this is our dp array. Now we have reduced the space from m cross n to m only. Okay, m only, or we can say minimum of mn, because there may be case, okay, this is row only basically. You will get better understanding when we solve the problem. Okay, so we have reduced the space, so we started with the recursive approach, after that we go with the memoization, after that we go with the tabulation, after that the space optimization. Okay, these are the different approaches. Let's get started with the code, then how can we solve this problem in the code. Okay, let's get started with the code. So let's start with the coding. Okay, so unique path, so first we will do the same thing that we did in previous questions as well. We'll make the util function. Okay, simply we'll return unique path utils from here, and because we are taking the index from 0, so it is m-1 and n-1. Okay, so our base case is if we have only one cell we have only one cell, we have m is 0 and n is double equal to 0, means our row and column both are 0. We will saying that it is there is one path, there is one unique path to reach from the start to the end if there is only one cell, because start and end both are at the same position. Okay, now we have to ask to our upside, okay, hey, upper cell, that hey, how many ways to reach at you, and similarly we need to ask our left side, hey, how many ways to reach at you. Okay, so if we are asking to the upper side, so when we go to the up, our row will decrease by 1 and column remains same. When we go to the back side or the left side, row remains same and column decrease by 1. Okay, now we have to calculate the total unique paths, so we will simply return return up plus left. Okay, so if you see here m minus 1 we are doing, here m n minus 1 we are doing, so we need to check the boundary conditions as well. Let's say if I'm at the second cell in the first row, so there is no upper, so we need to check if either of them, if m is less than 0 or n is less than 0 or n is less than 0, we are simply returning 0. Let's run this. Okay, let's try to submit this. Let's see if run or if it gives the time limit exceed exception error. Okay, time limit exceed. So how can we solve this? With the help of dp memoization. So need to take a dp array, and this is m and this is n. Okay, need to pass dp here, need to pass int dp here. We can write here just. Okay, so now we have to pass dp in our function, and another step next we have to do, before calculating it again, we need to check if dp of row and column is not equal to -1. So we are checking -1, return dp of mn, m comma n. Okay, okay, now we have to fill this dp with -1 as well. So how can we do this? From int I equal to 0, I'll go to the first row and I plus plus. So for each row, arrays dot fill, what we will do, dp of I comma -1. Okay, so it's all the rows filled with 0 of -1. Okay, now dp is here, dp is there, dp is okay, everything seems fine. Let's run this. Okay, so before here, if you see dp, we can, before returning also we can write the dp of mn here and semicolon here. Okay, so let's run this again. For I is equal to 0, I is less than n. Okay, so we are filling each rows 0, row 1, row 2, so it will go to the m. Okay, so we are able to submit this. This is the memoization approach. Now let's go with the tabulation approach. How we will go with the tabulation approach? In tabulation approach, okay, so no need to this line. Okay, so first we have to fill the base case. For the base case, or we can simply write, if int I equal to 0, I is less than row, total row I plus plus, for int j equal to 0, j is less than n, j plus plus. So our base case is if we are in the first cell means if I is double equal to 0 and j is double equal to 0, what we will do, we will simply put dp of ij is equal to 1, I j is equal to 1. Now no need to go next, so we'll do continue. Okay, now what we will do, let's copy this both this. Okay, so here dp will come here, dp will come here. Okay, dp of m, dp of n is here, dp of m. Okay, dp of n will come here. Okay, at last we have this one. Okay, so so our row is I and j, so here we will go with the I and this will is j, and similarly this one is row is I and column is j. So our dp of I and j is equal to up plus left. Okay, and at last this we will return dp of m minus 1 and n minus 1. Okay, let's remove this one. Okay, so we are dp of I minus 1. So let's say I'm in the second cell in the first row. So before need to go in the I minus 1, I cannot go to the upside, so I will check. Let's say int up equal to 0 and int left equal to 0, int left equal to 0. So for this one, if I is greater than 0, we will do this one. Similarly for this one, if j is greater than 0, we will do and remove this line and remove this line. Okay, if let's see if there is some format code. Okay, so bracket here is this one, this is the m minus 1 n minus 1 we are returning. This is the for loop again. This is if, let's say if it works. Okay, so here it will not come. Let's reformat it again. Let's run this. Okay, we need a semicolon here, up left, similarly here. Okay, now it's formatted. Let's run this. Okay, it's working fine. Okay, yes, now we are able to do it with the tabulation. Next one is the space optimization. As we can see, we can take a, what we will do, with the help of a temporary array, or we can take, let's say we have a previous array equal to new int new int number of the columns, and let's say we have a current array. We have a current array. In current array equal to, let's say we have the current array, and what we will do, so we have to calculate the current array. We have to first calculate the current array, new int n. Okay, so what we are going to do now, if you see, if I is equal to 0, j is equal to 0, what we are going to, we are filling our current array. We are filling with our current array. Now what we will do, I minus 1 means we our previous array, and here also our dp of I means our current array, and dp of I we are filling here is our current array, and in this simply we will return our previous array of n minus 1. Let's say dp is not there, dp is not there, n minus 1, n minus 1. Let's run this. Okay, so current is new of n, previous of int n, I is equal to 0, I is j, if we are putting into the current. Okay, after that what we have to do, we have to swap as well, because now our previous will be our current only. Our previous will be our current only. Okay, okay, that's great. We are able to submit now. So now we see there are the recursive approach, memoization approach, tabulation approach, and space optimization approach. We can further optimize this. We will see in the other videos. Okay, so thank you to watching this video. If you like this video, I request you to comment so that I can see if you are interested in these type of the videos, and if you see there is any problem, I'll happy to resolve your problem. Okay, thank you guys, please like, subscribe my channel. Thank you.